ultimately getting to systems of inequalities. But for right now, let's just talk about just straight up inequalities. If I have an inequality, x plus 2y less than or equal to 4, you do know that what that adds to it, of course I've got a line, x plus 2y equals 4 would be a line. The inequality adds to that what? Well, you're going to shade one side or the other of that line. Because when you add the inequality, ordered pairs on one side or the other of that line are going to work in this inequality just the way it works out. Okay? So what this is going to amount to when I graph it, this is going to be a line, though, with shading. Shading one side or the other of that line. So to graph it, yeah, you graph the line, first of all. The line would be the x plus 2y equals 4. So we graph that line. And graph it however you want to. Give me 2 points out of that. And the intercepts are good ones to find there. Your y-intercept, set x to be 0, so I'd have 2y equals 4, set x to be 0. So I have the y-intercept is 2. And then my x-intercept would be set y to be 0. So that would be x equals 4. So that's my x-intercept. You can graph it how you want to. Put it in y equals mx plus b. We've done those quite a bit. But yeah, there's my line. Okay, so I do have, and note there, I do have the line is part of this graph because I got the equal to part. Because that's what the line is. It's x plus 2y equals 4. That's the line. All right, but the inequality then, like I said, comes in with the shading. And what you want to do on the shading is just pick a point not on the line, and usually 0, 0 is a good choice there. And check it out and see if it works. If it doesn't work, then go to the other side. If it does work, shade that side. All right, so let's check 0, 0 in my inequality. That's an easy one to check. It's not on the line. So yeah, just plug in 0 and 0 for x and y. And then ask, well, is that true or not? That 0 is less than or equal to 4, and that is true, isn't it? So 0, 0 works. Zero, 0 does work. So there's 0, 0, so I want to shade it, the side with it on it, so that would mean shade here. Okay? Now, another little, let's use the same thing, except x plus 2y is strictly less than 4. Meaning I don't have the equal to part. Well, since I don't have the equal to part, what, technically speaking, then is not part of this solution set? The line itself. So yeah, I'm missing the equal to part, and so the line itself is not technically part of the solution set. And so we still have the line as a boundary, but technically it's not a part of the solution set, and so to note that, then we just use a dotted line, okay? Yeah, if you don't have the equal to part, you are going to use a dotted line. It's still less than, so 0, 0 would still work, right? So I'd still shade this side. of the graph. So everything stays the same except dot the line in. Okay? All right, well, it works the same if you have parabolas, circles, same idea. Let's look at one of those. If I have y is less than or equal to x squared minus 9. Y is less than or equal to x squared minus 9. Well, we're not talking about a line here because as far as the equal to part here goes, we've got y equals x squared minus 9. So if I graph that, what is that? It's a parabola, right? And this one's a fairly easy one because it's just the x squared parabola shifted down 9, so the vertex would be at 0, negative 9. Yeah, it's just the x squared graph moved down 9, so it looks like that. And if you wanted, you know, a couple other points, do your negative 1, positive 1 thing. Both of those would be y value negative 8, wouldn't it? Same thing for 1. So you've got negative 1, positive 1, negative 8. And we do have the equal to part, so it is solid line. But what else do we have on it? A little bit of shading, right? So in this case, it's either going to be inside the parabola or outside the parabola. How do I figure out which one? Try 0, 0, yeah. So for the shading here, let's check 0, 0. 0 is less than or equal to 0 squared minus 9. 0 is less than or equal to negative 9. That's false. So 0, 0 doesn't work. So I wouldn't shade inside because I would be shading 0, 0. So where would I shade? Shade on the outside. Okay? So it's the parabola and then everything shaded outside of it. All right. Question number 2. All right, well, a couple others. Here we haven't done a whole lot of vertical and horizontal lines, but we do have them quite a bit on these inequalities, so let me mention those. Yeah, if I have x is less than or equal to 2, well, first of all, the equal to graph, the graph of x equals 2, that's just saying, the way I usually explain it is the value is always 2. And so, yeah, you got 2, 1, 2, 2, 2, 3. You got the vertical line. X equals 2 is a vertical line. And so the inequality then is shading of that either side of that vertical line, but here we're talking less than x is less than 2, so that would be shading to the left here. We have y greater than 3. Well, we're talking graph y equals 3. What is that? Y equals the number is a horizontal line because the y value is always 3, so that's 1, 3, 2, 3, 3, 3, negative 1, 3, so that's the horizontal line, yeah. Whoop. Now, just so happen here I don't have the equal to part, so it's a dotted horizontal line. And then I want greater than that, so that's above the line. Okay? So we haven't graphed a whole lot of vertical and horizontal, but x equals the number is a vertical, y equals the number is always a horizontal. Okay? All right. So, what I intend to do with that today is talk about systems. Of inequalities. Systems of inequalities. So we've got more than one of those. All right, let's do x minus 2y less than 5, x greater than or equal to negative 4, and y is less than or equal to 3. So this is a system, and obviously we have inequalities here. And so the solution to the system of inequalities is solutions, because there's going to be quite a few solutions points. Solutions are going to be where all the graphs overlap. So all three of these are going to be shaded graphs, but when you put them in a system, the solutions are where, graphically speaking, they all overlap. Okay? So on the first step would be graph each one of these. If I graph the line there, x minus 2y equals 5, well, I'd have what? The x-intercept would be 5. The y-intercept would be x is 0, so that would be, what, negative 2/5? I mean, negative 5/2. That's one way you could do it. Okay. Five x-intercept, negative 5/2 y-intercept. And I don't have the equal to part, so that tells me dotted line. And since I want to know where the graphs all overlap, I'm just going to document here which side I would shade without actually maybe doing all the shading. You can if you want, but as far as the shading goes on that, check 0, 0. 0 minus 2 times 0 is less than 5. Yeah, that's true. Okay. So I would shade the 0, 0 side, which would be this side. So let me just say I'd be graphing above. All right. The others. Well, the other two are a little bit easier. What about x is greater than or equal to negative 4? Well, x equals, that's a vertical line, right? X equals a vertical line. So we'll go through negative 4 on the x, vertically speaking. Oops. And it is equal to, so I just would do that one solid. And I want greater than, that one's easy call there. It's just everything greater. So right now it'd be, overlap-wise, it'd be right up in here. But then I've got the third one. Y is less than or equal to 3. Well, y equals 3, that's a horizontal line. Y equals a number is always horizontal. So at y equals 3, and I want less than, so what am I looking at as far as the overlap of all three? Well, it'd be above this line, then to the right of the vertical line, and then below. So I'm talking about this triangular area, aren't I? It's where all three would be overlapping. So yeah, it is this triangular area, including this line, not including the slanted line there. But is that okay? Be all that right in there. Okay? Question or concern? Okay, before I leave that though, let me also talk about these corners here, also known as vertices. If you need to know where those vertices are, you see how we could come about those? Well, this one, probably the hardest, most difficult one. This one would be easy because that's what, -4, 3. So that would be -4, 3 because they're vertical and horizontal. But the other two, all right, the other two, let's talk about those. This one is where we cross on the line, slanted line, and then the horizontal line. So it's these two. Who could tell me how I could get that? Well, if you just kind of treat it like a system, I've got y, basically y equals 3 there, just the equals 2 there. I've got y equals 3, so if I plug in 3 right there, that would give me, of course that's obviously the y value would be 3. It's got to be 3. To get the x value, plug in y to be 3. Make sense? So the x minus 6 equals 5. Plug in y to be 3 there, because that's what y has to be. And then add your 6. So yeah, it's way out there at 11. So it'll be 11, 3. So yeah, just look at the two equations that are overlapping there. So this one, what would this one be then? Well, we've got the x value is -4. So how would I get the other one? Well, then I'd come back here and plug in -4 for the x. And then I could find the y. Okay? Is that okay? 4. Add 4 and divide by -2, so it's -4.5. 4.5. Okay? So if you need to find those vertices, the corners, on that one, that's the way you go. Okay? All right. So how about this one? 4x plus 3y greater than 6. 4x minus y less than -4. This one just has two lines. Again, however you want to graph those. I think I'll change gears here. Let me talk about this one. Let's graph 4x plus 3y equals 6. Let me do it this way. Subtract 4x and divide by 3. So you get y equals -4/3 x plus 2. Both those divided by 3. Do the y equals mx plus b way. If you like that way better, that's fine. Because I've got a y-intercept in of 2. Rise over run, -4 over 3. 1, 2, 3, 4. 1, 2, 3. So there's that. It's a dotted line. So if you want to do those that way, by all means, do so. All right, then the shading for that would be, you could check 0, 0, 0 for x, 0 for y. 0 is greater than 6. Nope, false. So that would be this side. 0, 0 is down here. So we'd shade over there. Is that okay? Go ahead and shade this one since it's just got 2. Won't be quite as messy. All right. What about the other one? Well, the other one, I've got 4x minus y equals -4 for the line part of it. Switch the places there, so it'll be 4x plus 4 equals y, so y equals 4x plus 4. So there I've got a y-intercept of 4. and a rise to run of 4, so that would be up 4 over 1, so also dotted. Shading on it. 0, 0. 4 times 0 minus 0, is that less than negative 4? Wrong again, okay? So 0, 0 doesn't work, so I'm shading on this one. Do a little cross action there. So where's the solution? Up here in the V, isn't it? Right here, because this part is just in this, and this part is just in that one. This right in here, that's in both, isn't it? So that's the solutions. Meaning everything in that part there would work in both of these systems, on both of these equations in this system. Anything outside of it won't work as far as in both equations. All right. Let me show you one more here. Is that okay? All right, one more. How about y is less than or equal to x, and y plus x squared is greater than or equal to negative 6. Y is less than or equal to x. Y plus x squared greater than equal to negative 6. All right. First point. This one right here. I'm talking y equals x. What does that one look like? Well, that one is a good one for y equals mx plus b, isn't it? Because yeah, that one means y equals x plus 0, so the y-intercept is 0, the slope is 1. So yeah, that one's 0, rise 1, run 1, keep going. It's got the equal to parts, so it's the reason I bring this one up is because if I check the shading here like we have been, can I use 0, 0? Yeah, I can't check 0, 0 because it's on the line. So if 0, 0 is actually a part of the graph of your line or your curve, you can't use it for checking. What do? Well, you just go to another one. We could use 1, 0, check 1, 0 or 0, 1, either way. But 1, 0 down here. Something other than 0, 0, something not on the line. So if I check x is 1, y is 0, that is true, isn't it? That would work. So 1, 0 works, so I'd be shading all of this down through here. Okay? Second part. Let's talk about that one. Well, the equation is y plus x squared equals negative 6. What do you got there? Parabola? That one's a parabola. And my suggestion would be move that x squared over, and we have y equals negative x squared minus 6. And so what do you know about that? Flipped over, inverted parabola, upside down parabola, opening down parabola, and that one shifted down 6, isn't it? So that puts the vertex, if I take my parabola, reflect it, and then move it down 6, that's going to move it vertex-wise down here. They won't get too complicated, I don't think, on the parabolas. So that's the vertex down there. If you want to, then get your negative 1 and positive 1 point. So if x is negative 1, we'd have y equals negative 1 squared minus 6. That's negative 1 minus 6. That's negative 7. So it would be positive 1. So there it is. The other one we had, we shaded outside, but how do we figure out If it is outside or inside that parabola, well, just check 0, 0. We could check 0, 0 here, couldn't we? So it'll be 0 plus 0 squared greater than or equal to negative 6. 0 is greater than negative? Yes, true. So again, we want to shade the side with 0, 0. So again, it's the outside, isn't it? Whoop. And I probably want to go the other way with my so outside of all that, yeah, it's going to be this part here. Everything down below this, but outside of the parabola. So it's all that, just up to that parabola, though. Right? This part is below the line, but it's inside the parabola, so it's out. This side's